for all limits always. So we see the answer is 2 just like we suspected, which is the slope of that line. And the problem would have been no different no matter what point they would have selected from what we said before, that slope is constant.
Question.
Yeah.
Well, can you just like hold this thing down? Like block.
This little guy?
Yeah. Yeah, that's perfect. Thank you.
Any questions about example 1? All right, let's take care of example 2 then. 22. How about didn't stop this one? 22. Who will remember what to do in this problem? Same problem, but the function is now the radical function, radical x minus 1. And the point of concern is 2, 1. Right, find the slope of the tangent line of the curve, which means the slope of the curve. What is this silly thing? I didn't draw the line, because you know what a line looks like. Let's just look at this real quick. X minus 1 on the inside means it moved to the right 1. So basically, like that. Root x minus 1, 2, 1, 2, 1. Somewhere there, kind of like this. So we're finding not the line, not the tangent line, but the slope. Right? We're find the slope of the tangent line is what we want to find. Okay? We're going to find the slope of this thing right now, which we're calling the slope of the curve. Right? Delta x or some delta y this line has, right? We're trying to find delta y over delta x for that line right there. M tan. All right. Here's the definition. Limit as h approaches 0. So first thing we do is we take the function itself, and we're going to put in a plus h. What is a in this context?
Root x minus 1.
Well, the function is root x minus 1. What is the a we have to put inside?
2.
2. So we're going to put 2 plus h inside this expression. So the root of 2 plus h minus 1 on the inside minus function with just 2 plugged in, right? So maybe just eyeball that and tell me what it is. Again, they gave it to us over here this time. They're giving you the full point. So this is certainly 1, right? They're giving you f of a for these problems, right? This is a f of a right there. And the bottom has an h. You need to compute this limit, and then we will know the slope of this tangent line to this root function.
You have to take the conjugate.
Conjugate, Roger. All right. So, conjugate. So I need to multiply by root of 2 plus h minus 1 plus 1 over root 2 plus h minus 1 plus 1. This is what I was referring to. Oh, here, it looks like it's covered the whole thing. This is what I was referring to before in chapter 2 when I was saying these techniques, the few that I showed you, factor and cancel, conjugate, things like that, are going to follow over into chapter 3 a little bit of overflow. While we're using the limit definition of derivative. We'll establish rules later today, and we'll alleviate this burden of using this definition all the time. So we'll apply by the conjugate. But certainly there'll be questions on the test regarding using the limit definition. And you should expect one on the final too. I can imagine there's not one. I don't know, I can't just get it. All right, so when you compute the conjugate, all right, something times this conjugate, so all you end up doing is taking the root times the root, which removes the root, right? Square root squared is the thing inside, is the radicand. So you have 2 plus h minus 1 on the inside. 2 plus h minus 1 minus the square of the, right? Minus 1 squared. So minus 1. That takes care of the conjugate. On the bottom, all we did before was just align this next to the h in the denominator. So h, and then root 2 plus h minus 1 plus 1 lift. Agreed? I remove the parentheses inside the radicals because they're not doing anything, right? 2 plus h minus 1 is the same as 2 plus h minus 1. I'm going to have to have the parentheses in here or not at that stage. All right. You add this together, you just get h, correct? The top is just h. So now they just have a simple factor of h above. It's going to cancel with this factor below. What we expected before, right? That the factor of h will cancel. All right. So it should read now a limit as h goes to 0 of 1 over that parenthesized stuff. The root of 2 plus h minus 1 plus 1. Is it just 1?
Because because h goes to 0, you have 2 plus negative 1, which is 1.
You're saying the radical is just the number 1.
Yeah, and then square root of 1.
Yeah, because
It's 1 itself, so 1 over 1.
Well, don't forget this plus 1 here.
Wait, what? 1 over 2?
1 half.
What do you do?
So at this stage, now that the h factor, the factor of h has been removed, so the bottom is no longer heading towards 0. Now this thing is continuous at this location for h, so you can go ahead and plug the 0 in. You get 2 plus 0 is 2, minus 1 is 1. The root of 1 is 1, 1 plus 1. I'm not going to mess that up, it's 2. And the top stayed 1 the whole time.
Yep.
Huh? So now we know the slope of this tangent line here, which is the same as the slope of the curve, is a rise and run of 1 to 2, right? Slope of 1 half. That's the slope of that line right there, which is the slope of that curve right there. Right there, not the one right there. It's never going to be 1 half again, right? It was larger than 1 half, although from 0 to 1, it was always larger, or sorry, from 1 to 2 is always larger than 1 half. And once it passes what's that, 2? Passes the 2 mark, it is always smaller than 1 half. Agree? Just by looking at the curve. Agree. Okay, you're getting the hang of it now, yeah? Try one more. I'm worried about you. 21.